Today you're going to learn how with Grasshopper you can create brick facade based on the project Crystal House from MVRDV, combining traditional terracotta bricks with solid glass bricks. We'll try to recreate dissolving effect using parametric techniques, positioning traditional bricks on the glass one, which appears to be floating above the ground. Let's get started. Hi guys, Lazar here. In first part of the tutorial we are going to define the dimension of the bricks, then we will set the brick pattern, later on we will trim the openings, and in the last part of the tutorial we will apply this dissolving effect. So if I zoom in this picture, we can see that we have two different sizes of the bricks, the normal brick and this double one. So this large one is twice the size of the normal brick, and we can see the center of these two bricks are positioned in the same vertical axis, and we should keep that in mind. The dimension of the normal brick is 65, 105, 210, and the double brick, or the large one, it's 65, 210, 210. So basically twice the size of the small one, because the normal brick it's 105 and 105 has this dimension. Okay, now I'm going to disable the final output. We have predefined Rhino geometry because in this tutorial the focus is just on the facade wall. So we are going to import this facade wall in the surface container. Then we need to create the contours along z-axis, and the horizontal contours should be on the distance of 65 millimeters, because the brick height is 65. My Rhino unit, it's in meters, so that's because I set here 0.065, and this will be the distance between these horizontal lines. Okay, so first, in order to create these horizontal contours, we need to have a solid surface. So we don't need these openings. In order to have a solid surface, we will create the bounding box, but this bounding box should be positioned in the same plane as the surface. So in order to have a surface plane, we'll connect the surface with the isPlanar component in order to have the plane. You can see it here, and that plane will be placed in the P input of the bounding box. As this surface is flat, the output will be a flat box. In order to have the surface, we'll just place Deconstruct BREP, and in the F we'll have untrimmed surface. So instead of having surface with these openings, here we have untrimmed surface. Okay. Then this surface will be placed in the contour component. The start point of the contour will be the bottom point of this bounding box. We can evaluate this surface placing a face with the component bounding box, and if I turn this on, here we have the bottom point of the surface. You just need to position 0 in the W input. So let me just copy this one to explain how this works. If we set to 0, it means it will take out the bottom point of the surface. If I move it to 1, it will extract the top point of this surface. In the point output, I will place here in the P input of the contour. So this is the start point of the contour. The direction will be the Z direction. Once we have these three inputs, we just need to define the distance between the contours, and the distance will be actually the brick height, which is 0.065 or 60 millimeters. And if I turn this on, we have horizontal contours on the facade surface. Okay, now we need to divide this into two lists. So the first list of the lines will be these guys, every second one. So on these lines, we're going to position the double brick. And on the rest of the lines, we're going to position the normal bricks. Once again, I'm going to show the facade detail. So on these lines, on every second line, we're going to position this double one, and on the rest of this, the normal one. Okay. So in order to define this into two different lists, we will use a split tree component. And in the splitting mask, you will need to set this syntax. It means that the paths with even numbers will be positioned in one list, and the rest of this, so the paths with odd numbers, will be positioned in another list. Let me open first how the data tree looks like. So in each path we have one item. So each line is positioned in a single path or in a single branch, and we can, using this splitting mask, we can define. So here we have one set of lines, and here we have another set of lines. Okay, so now we need to position the bricks on these lines. So we will use divide length and in order to create the points. Now these points will be used to position the bricks. So using divide length, in the C we'll place these lines, and in the L we will position, and the brick length is 21 centimeters, as we can see here, or 210 millimeters. Okay, so this will be positioned in the L. So every second line has the points on it with the distance of 21 centimeters. Okay, now we need to do the other set of lines, but in this case the distance between the points should be 21 centimeters divided by 2, as we have here. So it's 105 millimeters or 0.105 meters. So I'm going to divide this in 2, and I'm going to place in the divide length. You can see that we have one step in between, which it's extend curve. What does it mean in our case? If your surface, that facade surface, it's longer a little bit, and you position this brick in the center, like this one, this is the logic that how we are going to position the bricks, you will have this left over here and here as well. So that's why we need to extend these lines in order to position the brick in this place, in this part, and later on we are going to trim it. In our case, we'll not have these leftovers, but just in case, for example, if you have the surface which is longer, or for example, if you have the bricks that is shorter than 105, then you will have these leftovers. That's why we will extend the curve. Now we have these two set of points. Now we need to position the bricks. Okay, the first step is to define the plane where these bricks will be positioned. After that, these points will be used as the origin plane where the bricks will be positioned. Okay, so let's go back here in this step where we define the plane where the surface is positioned. Then we're going to deconstruct this plane. Then we're going to extract the X and the normal vector of the plane in order to create the plane where the bricks should be positioned. This will be the horizontal frames. So using deconstruct, we will use the same origin. Here we will use the X as X of the new plane, and the Y of the new plane will be the normal vector or the Z vector of this one. So if I turn this on, we'll get horizontal frame. Now this plane should be used as a plane with these origin points. There is one step again in between. Let me show you. If we directly connect construct plane in the plane origin, and this should be plane origin, we get these planes. And if we create the bricks, those bricks will be placed in the opposite direction. So you can see we don't want to place the bricks below these curves. We should place these bricks above this curve. So that's why we need to flip y direction of the plane. And once we flip this direction, let me position it here, the orientation of the bricks is correct. Let's define the dimension of the bricks, and dimension of the bricks are this one. So the x, it's 210, the width it's 210, and the height it's 65 millimeters. And that's how we can create these double bricks or the large bricks. Now we need to create the normal bricks or the small ones. The difference between these two is that these points will be the center of the orientation of the bricks. So there is one small difference. The plane will be placed in the B input. In the Y, we'll place the brick width. In the brick height will be 65 millimeters. Just in the brick length, instead of having a domain, because here we need to place the domain, instead of having a domain from 0 to 105, we are going to create domain from minus 105 divided by 2 to 105 divided by 2. So in that way, if we have the center in both of these directions, the bricks will be created. If we set from 0 to 105, the brick will be positioned like this. So this is the method how we want to position the bricks. That's why we'll place this domain. So in the X, first we'll divide 210 by 2 in order to get 105, and then 105 will be divided by 2. So here we have minus 0.0525, and here we have 0.0525, or 105 divided by 2. So once we create this domain, we'll place in the X input. If I turn this on, the bricks will be positioned. All right, as we created bricks on the whole surface of the wall, we need to trim these openings. So first, let me turn off this one, and we will take out this surface. We are going to extrude in both of the direction. So the direction of the extrusion will be the normal vector of the surface. Normal vector we can get from the east planar plane. If you connect vector with the plane, you will get the normal vector. Or you can deconstruct and take out the exact vector. It's the same. Then using this vector, we are going to extrude in both directions. That's why I place here 0.5 and minus 0.5. In the amplitude, here we have two vectors, and these two vectors I will place in the extrude D input. And we have two closed B wraps. Now I want to join them in a single B wrap. Okay, here we have a single closed B wrap. In the next step, using collision one many, we'll find only those bricks that has intersection with this B wrap. So in the C, I will place the bricks, and in the O, or the obstacles for collision, I will place this closed B wrap. The output, it's true or false, and using call pattern, I will take out only those bricks that collide with this closed VRAP. And these are the bricks. Now we need to trim those bricks. So in order to trim them, I will use solid intersection. This takes, as you can see on my computer, 50 seconds to calculate everything. So from these bricks, I want to remove, or I want to intersect them with this closed VRAP. So once we intersect them, we'll keep only those bricks and the part of the bricks that are inside. So keep in mind, this takes around 1 minute to calculate everything. Okay, and once I turn this on, we get the result that we need. In the last part of this tutorial, we need to create this dissolving effect. Before we continue, I just want to mention the extended version of this tutorial, which will be focused on rendering. First, you will learn how to create different types of a single brick texture, how to map them on a brick wall, and how to randomly apply those different map textures on a brick wall. Based on those textures, we'll create V-Ray materials. In addition to that, we are going to apply glass material, you will learn how to add V-Ray infinite plane, the lightning, and on top of that, we'll create renders using V-Ray for Grasshopper. You will also get access to all our extended tutorials and project files. So first, we will flatten this tree. And here we have 8,940 VRAPs or the bricks in our case. Then we need to find the Z coordinate of the center of each brick. So in order to take out the center, I'm going to use box properties, and I will connect with the bricks. That's how we can get the center. Then I'm going to deconstruct these centers in order to have the Z direction of the bricks. So first, let me explain the logic behind what we are going to do. Imagine we have a set of points, and we deconstruct a Z coordinate of all of these points to the value from 0 to 1. Now let's generate the set of numbers from 0.5 to 0.7. And the amount of these numbers should be equal to the amount of these points. So here we should, let's say in total we have 1000 points with the Z coordinate from 0 to 1. We're going to generate 1000 numbers from 0.5 to 0.7. And then we are going to check, are these points here in this range, or are their Z coordinate it's larger than the Z coordinate of the original red points. Okay, what we know in advance that the points in this area here for sure will have a smaller Z coordinate than the points in this area from 0.5 to 0.7. So if it's larger, then the value output will be 0. But you know also that in this area, all the points will be or will have the Z coordinate larger than the Z coordinate from the points from this area. So the value will be here 1. So this is the method how we can distinguish these two lists. But in this part here will appear that dissolving effect. If we take this original point here, and we have a bunch of randomly generated points in this area, what we know is that the higher possibility will be that this point will have smaller Z coordinate. So that's why points closer to 0.5 will have the higher possibility that their Z coordinates will be smaller than the randomly generated points from in the domain from 0.5 to 0.7. But if we have an original point position here, if we compare their z coordinate with the randomly generated points from 0.5 to 0.7, it's a higher probability that their z coordinate will be higher than the z coordinate from these randomly generated points. So using this logic, we'll create that dissolving effect. And let me explain how that works. So first we have this, how I call them, original points. We're going to deconstruct them and their z coordinate will remap to 0.1. And we're going to check if these numbers are larger than. We'll take the same amount of numbers as we have these points. Then we're going to create a range of number from 0 to 1. Using Graph Mapper, we can remap them. So this is not necessary, but just in case you want to create like a nicer transition. So, and then these points from 0 to 1, we will remap to the points from 0.5 to 0.7. And we compare these two lists. There is one step in between that in order to create randomly generated points from this domain 0.5 to 0.7, we will jitter or we will shuffle the list. Don't forget in the J input to set 1. It means that the list will be completely shuffled, and in the S you can set the iteration. Okay, as we have here randomly positioned numbers from 0.5 to 0.7, we'll check are these numbers are larger than these guys. Using these Boolean results, we'll place in the pattern of the dispatch. What you want to dispatch? Actually, you want to dispatch these bricks. So the list of the bricks I will place in the L, the pattern we get here we'll place in the P, and in the A here we'll get the bricks with the Z coordinate of the center point. It's larger than this randomly generated number from 0.5 to 0.7. Here we get the bricks with the Z coordinate of the center of each brick. It's smaller than the randomly generated number from 0.5 to 0.7. Then if I turn the custom preview material, we will get this dissolving effect. And using this method, you can divide the single list of the bricks into two different based on the parametric dissolving method. And for example, if you want to change the iteration, you can set the different number here, or if you want to change the transition, you can play with the graph mapper, or if you want to have like a bigger transition, instead of 0.5 you can set, let's say, 0.3. Then the transition from the glass to the brick material will be higher. Basically, playing with these parameters, you can adjust the design based on your needs. Before I wrap this video up, I would like to share something with you. If you're in architecture and you're interested in learning more about Rhino and Grasshopper, but you're tired of searching through thousands of tutorials online and wasting so much time doing that, and you're looking for a structured learning approach with one-on-one support, we created a course called Rhino for Architects that will guide you through all of the basics of both Rhino and Grasshopper. In addition to that, we'll be covering some advanced modeling techniques using sub-D division tools for Rhino 7, which will allow you to create any kind of geometrical shape that you imagine. When it comes to Grasshopper, we'll explain every single essential component with examples and homework files, so even if you're a total beginner, you'll be able to understand the logic and mathematics behind the program. On top of that, we'll teach you all about various plugins for Rhino that are used in architecture, such as V-Ray, Visual Arc, and even Bongo for architectural animation. Lastly, we'll cover architectural presentation, creation of diagrams, and a couple of case study projects. If this sounds like something you would like to check out, feel free to schedule your free Zoom call with us in the first link in the description. On this call, we will evaluate your current skill sets, determine if this course can help you out, and on top of that, we will share our learning platform with you so you can get a better idea how all of that looks on the inside. Click on the link below the video and we'll talk soon. Take care.